Hi, I'm Pete Rivard. I'm a principal instructor in the Graphics and Printing Technologies program here at Dunwoody. I teach pre-press and graphic design, and today's topic is structural design for packaging. Okay, so now that we've introduced you to the basic software itself, we're going to talk to you about the process of converting your rough sketch into a formal die line that eventually will be used to drive our sample table. Now, all of you designers will have access to this book right here. This is a very important book right here for structural designers because most of the possible folding cartons out there in the world that we need have already been invented. You're not going to be expected necessarily to design a carton from scratch. You'll probably be picking up what's known as a standard and then modifying that standard to fit your product. In most cases, you will find a style that fits your product fairly well, and it'll be in this book somewhere. And once you've identified your style, you'll be able to pick up a standard in Artio's CAD. And that's what we're looking at right here. This menu right here is a part of Artio's standards catalog. And in this are literally thousands of already designed carton styles that we start with. So what Nate has done in this case is he knew that he needed a tray, and he basically knew how that tray would have to operate, and he didn't care whether his style had a window in it or not because he could modify that, he could put that in later on, but he wanted a tray that had a hinged lid. He wanted the lid to be part of the tray mechanism as opposed to a separate element. So he found this standard, and what he has to do is link this standard up with a corrugated thickness. In this case, we use what is called E-fluting. This is corrugated material that is 1/16 of an inch thick. So once he finds his standard and links it up to the base material right here, then he can start inputting dimensions and creating his own carton. So let's go ahead and do that. So what he's got to do there is, let's go back and do that again because I want you to find that E flute, Nate. Okay, so we pick it up again from right here. So what you're going to do is, if you scroll down on the right-hand pane, you'll see the corrugated types down at the bottom, and there's an E flute category right there, or there should be. Go into corrugated boards, and there we go. That's your fluting right there. So we've linked up a carton standard to a specific substrate, and now what Nate has to do is he has to put in the length, width, and depth dimensions. And this is something that we just can't gloss over because the dimensions on a folding carton are not the normal dimensions as we would think about it. We need to think about this carton as sitting on a shelf because the length dimension, no matter how the carton is designed, is always the direction as the carton sits. It's the direction along the shelf or the direction that's parallel to the aisle as you push your shopping cart down the aisle. The width is always the direction back into the shelf itself. So this would be the face that's looking at you as you come down the aisle. This would be pushing back into the shelf right here. This would be the width. So we've got length, we've got width, and then the depth is the height of the carton when the carton is closed. And that's how we define folding carton dimensions, which is very important because shelf length in the Western world is divided into 4-foot lengths. And we always want to design knowing that we want to pack as many specific cartons into that 4-foot length as possible. Okay, so Nate's going to put in his dimensions so that they fit the particular product. Remember what those are? Probably a square, 5.5 and 5.5, and let's put an inch for your depth, and that's going to give us something very close. So what Nate now has here is he has a flat die line. Again, the solid black lines here indicate the cut areas. And in this particular layout right here, the solid red lines indicate ordinary folds, and some of these blue lines here indicate some more complex instructions, possibly a slit and score combination. But he's got the main panels of the tray, and the tray is presented to us with its two major surfaces, the bottom and the top, more or less right next to each other. Essentially, one of the definitions that makes a tray is that it sits on the shelf right on top of its largest dimension, its largest panel. That's always going to be the bottom of the tray, and then the lid will interact with that, and the walls will interact with that, but the largest panel on a tray is the base that it sits on. Now from here, Nate would take it further. He would put any windows in that he wanted. He would make any right angle corners into rounded corners if he felt like that would assist the closing function. And he's got to watch his gaps, which will make sure that the carton doesn't seize on itself when it starts being folded into 90-degree angles. He also has to make minor modifications because in something like a tray right here, this surface right here actually has to be expanded a little bit because it's got to come outside of the walls of the bottom section right here. So the top section and the bottom section can't be equal to each other. The lid has to be ever so slightly bigger in both directions to make sure that this thing opens and shuts. When Nate has finished his design, Artios will save this file in its own native format. Artios' native format is .ard. It's like a TIFF file or a JPEG or a GIF, any of the other file formats that we're familiar with. Artios' native file is .ard. Our table doesn't understand ARD. So it will be important for everyone to take their ARD file and convert it or export it to what's called an HBG file. And that HBG file is the language of our cutting table. And ultimately, we will send the HBG file from your laptop to a location available to this computer right here, and this computer drives the table.